Okay, Algebra 1 fans, so we're on to notes. And it says day 55. It's not necessarily what that day is, but the topic for today is adding and subtracting polynomials. We've talked in the last few days about multiplying monomials. We've talked about dividing monomials, the rules for that, and now we're going to get into addition and subtraction. And what you're going to find actually is that this is kind of a review because the main idea for today is combine like terms. So, first thing before we start the notes, here's your joke for the day. What did the 0 say to the 8? Nice belt. Okay, so let's get to the notes here. First thing we'll do is we'll talk a little bit about vocabulary, and we'll do a little review here as well. A monomial is an expression that is either could be a number, could be a variable, or a product of a real number and one or more variables. So as an example, 3x squared is a monomial. 4x squared yz to the third is a monomial. The key is the exponents cannot be fractions and they cannot be negative numbers as well. Okay, so that's a monomial. Mono means one. Poly is many. So polynomial is basically many terms. So it's a monomial or a sum or difference of monomials. Okay, so for example, if we said 3x squared, that's technically a polynomial. Now it's a special case where it's only one term, so we call it a monomial, but you could say it's a polynomial. We could also say 3x squared plus 2. That's a polynomial. Now notice there are two terms here, so we call this a binomial. Bi is 2, like a bicycle is 2 wheels. If we said 2x squared minus 3x minus 5, that's 3 terms. That's what we call a trinomial. And we could keep going. So these are all examples of polynomials. Now, what we're going to do today is we're going to talk about addition and subtraction of polynomials. And then in a couple of classes, we'll talk about what happens when you multiply them together. So this is kind of a review because we've already talked about combining like terms. We actually did this in the first week of the first semester. So example number 1, add the following polynomials: 2x squared minus x plus 5x squared plus 3x. So we have two binomials which we're going to add. Now I'm going to show you two ways that you can do this. Method number 1 is underlining. And this is the one that I usually do when we're working a problem. Let me write this without parentheses. Because everything here is addition, when I'm adding both of these, I'm just going to drop the parentheses, so 2x squared minus x plus 5x squared plus 3x. Okay? That's what we're trying to add. And what I like to do is I like to underline my like terms. So it's 2x squared plus 5x squared. Now remember that when you multiply variables, you add the exponents. But if all you're doing is adding and subtracting terms, then the variable and the exponents stay the same. All you do is you add or subtract the coefficients. So 2x squared plus 5x squared is 7x squared. The variable doesn't change, the exponent doesn't change. When you add and subtract like terms, all that changes is the coefficient. But you can't combine these unless it's the same term. It has to be the same variable and the same exponent. That's an x squared, that's an x squared. I can't combine that with 3x because this is only x to the first. That's not the same kind of term. Now we do have, this is a negative x. I'm going to double underline that, and that's a negative 1x. And this is a positive 3x. Now one thing I've seen people do, and I think this is a good method, some people like to circle the terms that they're going to combine. Negative 1x plus 3x. So we look at the coefficients. Negative 1 plus 3 is 2. So that's 2x. Now the question is, what goes in front of the 2x? Is it a positive or is it a negative? Well, negative 1 plus 3 is positive 2x, so that's plus 2x. That's your answer. We can't go any further than that. Right? You're not multiplying anymore. Okay, so you can't say x squared times x to the first and add the exponents. It doesn't work. This is good. The other way that you could do this, though, is you could put this into two columns. So if we said 2x squared minus x, okay, I'm going to put that in the top part, plus 5x squared plus 3x. Think of this as an addition problem, okay, where you add the columns. 2x squared plus 5x squared is 7x squared. This is kind of like our system of equations that we were doing a few weeks ago. And then this is negative 1x plus 3x. So that's positive 2x. So it's two ways to get the same answer. It's up to you. You do whichever method you're more comfortable with. Okay? As long as it gets you the right answer and you're showing your work, then it's good. Number 2, we're going to add these two polynomials. Now again, because it's just a plus between them, I'm going to rewrite this. You don't need to do this, but I like to write this without parentheses. I get confused when I see all these parentheses, so I'm going to just write it without them. And I'm also going to write, you'll notice I put not minus k, minus 1k. I'm going to put that 1 in there so that I don't forget when I add it or subtract it. So here we go. We got 3h, positive 3h, positive 7h. 3 plus 7, that's 10h. Okay, now let's see. Positive 2k minus 1k. So what we have is positive 2 minus 1. So that's just plus 1. That's 1k. And let me get one more color here. Let's go with orange. Positive 4, positive 3. 4 plus 3 is 7. That's it. That's all you can do. You cannot combine an h with a k. 7 is just a constant, so that doesn't go with any of the variables. All right, and number 3, let's go ahead and do the column method. So I'm going to write 9m squared plus 16m minus 3. And then I'm going to write plus 2m squared, and I'm going to line up my variables. So m squareds, those are above each other. Plus 3m, that's lined up, and then minus 1. And now you just add the columns. 9 plus 2 is 11m squared. 16 plus 3 is 19m. Negative 3 plus negative 1 is negative 4. Negative 3 plus negative 1 is negative 4. Be very careful with that. And that's it. That's all we can do. Okay, now let's take a look here at the bottom. Whew, it's a big problem right there. All right, no problem. What we do is we take this and we go step by step. Take a difficult problem, break it into easier parts. I'm going to do this one without, I'm not going to rewrite it without the parentheses. I already know that the parentheses don't really matter in this problem. You have to be careful though here. Let's start with the variable that has the highest exponent. So you have a 6x to the third. 6x to the third. Now do we have any other x to the thirds in the problem? We do. We have a 9x to the third, and it's plus. 6 plus 9, 15x to the third. Okay, now do we have any x squareds? We have a 2x squared, and then we have a plus x squared. Let's put a 1 there, 1x squared. 2x squared plus 1x squared is 3x squareds. Now again, when you add and subtract like terms, you do not change the variable and you do not change the exponents. Very important there. Okay, let's see. Go to a different color here. Let's look at green. Now, 7 is a constant. Do we have an x term? Here's a negative 11x. And then we have a positive 8x. So we have negative 11x plus 8x. Negative 11 plus 8 minus 3x. And then the last one, we have positive 7, and we also have negative 7. Now, 7 plus negative 7, or 7 minus 7, is just 0. So we could put a plus 0 here, but we really don't need it. So I'm just going to cross that out. I'm going to erase that. And here's my answer. This is good. Okay, so the main idea is that you have to add and subtract like terms. So this is different from multiplying and dividing variables. We're just going back to adding and subtracting like terms. The variable and the exponent stay the same. The only thing that changes are the coefficients, which are the numbers in front of the variables. Okay, so flip it on to the back and we'll do the second half of the notes.